So we want to continue our discussion of the square of opposition, and I want to get right out in front of this. This is some complex stuff, folks. It's going to take actually quite some time really to memorize all these relationships on the square, and honestly it would take more time than we even have in this class for you to understand them deeply and really intuitively. So just know that going in that you don't have to get this right away. In fact, that's what we're going to do today. I'm going to give you some charts that will help you make sense of these relationships, the other relationships on the square of opposition. I'm a chart kind of guy. That's how I like to organize information. And I think these charts will help you as you start to memorize the relationships and as you start to analyze arguments for what people are implying in their propositions. Remember, we had those terms last time. Imply is what is folded into, right, the propositions, and infer is what somebody takes out of the propositions in the conclusion. I think if you look at these charts, they will help you in analyzing those kinds of arguments. So let's start off with the square of opposition, and yes, I actually want you to draw this again. I know you've already got it in your notes once, but go ahead and draw it again. It's just going to help you to start to get a sense of where the relationships are on the square. So pause the video and redraw the square of opposition. And notice that I've highlighted the one at the top that says contrariety. That's how that's pronounced, contrariety. And the one at the bottom, subcontrariety. And we're going to talk about those two relationships first. So here is a chart. All right, so we've got two columns for contrariety and subcontrariety. And you want to copy this exactly. So contrariety, first of all, exists between A and E propositions, and subcontrariety exists between I and O propositions. Now, A and E propositions cannot both be true. But I and O propositions can both be true. And you notice I've highlighted, or bold-faced and underlined those words cannot and can. Those are the really key parts of those definitions there. Now, A and E propositions can both be false, but I and O propositions cannot both be false. Then we see that if A or E is true, the other must be false. But with I and O, if one of those is true, then the other can be true or false. Now, if A or E is false, the other can be true or false. But if I or O is false, then the other must be true. So take a moment, make sure you have that chart copied exactly before we move on. Now, that information sitting in a chart is probably just utterly confusing. So let's get into this example here. We see the girl in yellow and the guy in blue. They're both looking at this treasure box, and the girl in yellow says all balls in that box are yellow. And the guy in blue says no balls in that box are yellow. And the guy in green is thinking, I guess I should open it and find out. And he does, and lo and behold, there are red, yellow, and blue balls in the box. And the girl says, but I thought I was right. And the guy in blue is kind of upset. He says, bring in a new box. The guy in green says, well, your statements could not both be true, but they could both be false. And the logic dragon is thinking, as indeed they are. Because if you think about it, what the girl in gold said, when she said all balls in that box are yellow, that was an A proposition. And the guy in blue who said no balls in that box are yellow, that was an E proposition. And as the guy in green rightly observed, they can't both be true. And if you think about it, that's pretty obvious. But they could both be false, as the case is. They are both false. So then they apparently bring in a new box. And the girl again says all balls in that box are yellow, making an A proposition. And the guy in blue says no balls in that box are yellow, making an E proposition again. And the guy in green says to Logic Dragon, he says, I peeked. He says, what if I told you all the balls are yellow? Logic Dragon says, if that is true, then Mr. Blue is in for some disappointment, right? Because if what she said, the A proposition, is true, then it follows just automatically that what the guy in blue said has to be false. But then the guy in green says, but what if I only said that Mr. Blue is wrong? Then Logic Dragon says, well, then Miss Yellow could be right or she could be wrong. I'd have to see for myself. Right? Because again, if the one is false, we don't really know about the other one, right? If you go back and look at your chart, that last box on the left-hand column there, if one is false, the other one could be true or it could be false. And then apparently they try it again. They bring in another box. The girl says this time some balls in that box are yellow, right? She's making an I proposition. And the guy in blue says some balls in that box are not yellow. He's making an O proposition. And the guy in green is thinking, oh boy, here we go again. And so they open it up, and she says, I'm right. And the guy in blue says, so am I. Let's do it again. And the guy in green is thinking, oh, is he serious? Well, let's focus on that for just a moment. With the I and the O propositions, again, if you look back at your chart, I and O can both be true. Some of those balls are yellow. Some of them are blue. So they try it again. And the girl says again, some balls in that box are yellow, an I proposition. The boy in blue says some balls in that box are not yellow, an O proposition. Once again, the guy in green confides in the Logic Dragon. He says, I peeked again, and there are some yellow balls. And Logic Dragon says, then Mr. Blue could be right, or he could be wrong. I'd have to see for myself, right? So again, if you think about your chart, if one of those propositions, I or O, is true, then the other one can be true or it can be false. And then they try it, well, they have the same box, I suppose, but Mr. Green says, but what if I only said that Mr. Blue is wrong? And Logic Dragon then says, well, then Miss Yellow would have to be right. Although they really should learn some new games, and I agree, this seems like this is getting kind of repetitious here. But think about that. If you look at your chart, if Mr. Blue is wrong, which means his statement is false, the O proposition is false, then the other one would have to be true. Now, let's go back to the square of opposition again. And this time we're going to talk about the two on the sides. And let me just say a word about these terms. And yes, believe it or not, I actually want you to copy the square of opposition again. You need to have practice at copying it because actually drawing it out helps you with memorizing and understanding where the relationships are. So as you do that, I'm going to say something about these words. The relationships are often called subalternation or superalternation. And in parentheses, I've got subimplication or superimplication. And to be honest, that just simply depends on the textbook that you're using. I first learned it as subalternation and superalternation. Your book uses subimplication and superimplication. So going on from here, we will use subimplication and superimplication. But I just wanted you to know the other terms as well, just in case you ever run across them, because some logic books use those terms instead. Now we're going to do another chart. This one's a little bit shorter. So Subimplication is a relationship describing how A relates to I. Notice how the arrow you drew only has one arrowhead, A going to I, and how E relates to O. A superimplication is a relationship describing how I relates to A. Again, there's only one arrowhead on that arrow, and how O relates to E. And these relationships are rather interesting. For subimplication, if A is true, then I must be true. Notice that it's bold-faced and underlined. Likewise, if E is true, O must be true. But for superimplication, if I is true, then A can be either true or false. Again, can is underlined and bold-faced. If O is true, then E can be either true or false. Now, with subimplication, if A is false, then I can be either true or false. Same thing with E. If E is false, O can be either true or false. And with superimplication, if I is false, A must be false. And likewise, if O is false, E must also be false. Now, again, I'm just going to talk a bit while you copy that chart. Well, folks, I know this is confusing. I know that just looking at the words in a chart and just seeing those sentences really makes absolutely no sense. And that's why we really want to look at these examples that are coming up. And again, realize this takes time. First off, it's just memorizing the relationships on the square. Just straight brute force memorizing. And over time, these relationships come to have more sense, and you begin to see them more intuitively. So now we come to the logic game. And the girl in gold says, what can you infer from these propositions? And Logic Dragon is thinking, when I said they should learn some new games, I meant something like Scrabble or basketball. And so she says, well, what about if this proposition is true? And what comes up on the screen, all swimmers are people who use goggles. So the fellow in blue says, that's an A proposition. So the I proposition, some swimmers are people who wear goggles, must also be true. And if you think about it, that does make sense. If they all wear goggles, then obviously some are also wearing goggles. She says, great job. Now, what if this is false? And she's got a new statement here. No dogs are animals that bark. She says, what if that's false? And the blue guy says, well, that's an E proposition. So the O proposition, some dogs are not animals that bark, may be true or it may be false. And if you check your chart, that's exactly what you would get from the relationship of subimplication. And then she says, let's try one more. What if this is false? Some logic students are people who do like dragons. And the guy in green says, well, that is an I proposition. So the A proposition, all logic students are people who like dragons, must also be false. And again, if you look at your chart on superimplication, you'll find that the guy in green got that right. Of course, Logic Dragon comes back and he says, what a horrible thing to say. How could anyone, especially logic students, not like dragons? Little Kangaroo says, don't worry, I like you. Like I said, I get that this is confusing, especially when you just look at the words. So seriously, watch the video again, watch it 2 or 3 more times. See if you can actually walk your parents through the video. If you can help them to understand, then that shows that you are really coming to understand it as well. And of course, the activities in the book will be good practice to see if you can really start to get these relationships on the square of opposition.